Hello! Hello, and welcome to the second session of 8 over the next 4 weeks, or I guess about 3.5 weeks now. Oh, and I've got the sound all funky again. 1 second. All right, there we go. So yeah, welcome to session 2 of my AAA modeling, character modeling stream. In which I'm going to be talking about various concepts related to retopologizing characters, topology for characters, building topology from scratch, or building off of a base like you see here. I'm going to be talking a little bit today about things like polygon distribution, topology for certain types of areas, why it's important to keep very even topology with lots of even distribution. I'm going to be talking a little bit about the way that I tend to lay out specific areas of, areas of a body, like a humanoid body for general topological use and such, whether it's being reused or being used for a specific character. And then for a good portion of tonight's stream, I'm mostly just going to be modeling and taking questions from the Twitch chat. Just as a reminder, this is part of a 4-week-long series where I sort of do a deep dive into 3D character topology with an emphasis on how it's sort of applied in AAA game development settings. So by the time that I'm finished, this guy that you see on screen right here is going to be pretty high poly. He's probably going to be in the neighborhood of 75 to 100,000 polys, triangles rather. And I'm going to be taking him all the way to the UV mapping stage. I'm not going to be talking about any materials or textures in this stream, and I'm not really going to be talking about things like rigging, except in the most abstract sense. You know, how your model affects how it can be rigged, best practices for making models so that they can be easily rigged, that type of thing. I'm not going to be talking about rendering. But I will mention many things having to do with, how a certain type of topology might render better than others, or how certain, certain things might render better than others if you want to get nice, smooth shading. That's something I'll definitely cover because it is more in line with how or it's more in line with the topic of modeling than it is with necessarily rendering or textures, materials, that type of thing. So this entire course is built around the idea of doing public live streams for 2 hours, and then an hour after that is devoted to a private stream, or rather a private Google Hangout with the program members, where they can come and talk to me, get feedback, ask me questions about the work that I'm doing. And it also allows me to do things like give critiques, do paintovers, do group discussion, and that type of thing. I still have some slots open for the program, and it's going through Patreon right now. So if you want to sign up to get into those private hangouts, you still have that opportunity. I have some other options if you don't want to pay the full amount on there. So yeah, if this seems cool, head on over to Patreon and look up XCK3D, just like it is here on Twitch. So, let's get down to business. Let's start talking about topology. Let's start talking about this character that I'm modeling right now. Let's talk about some of the things that I'm doing well, that I'm not doing well yet, or that I would like to do better. And let's talk a little bit about how I can improve what I already have. So, what I already have right now is this base that I worked on over the past couple days. I started this off on the stream on Tuesday, and I'm going to be doing a little more work on it today to make it a little more usable. I'm going to make it a little more, a little better for adding a head, adding some hands. I'm going to do things like cap off this tail. And I'm going to generally even out some of the topology in a lot of different areas that can cause some problems. I'm also going to talk about specific places where I'm using things like ingons, like right here. This might not be the best place for an ingon. a five-sided polygon. But that can be changed. But there are other places where I do have n-gons, like right here, where they're pretty helpful. So let's dive in. Let's talk about the first big topic that I want to talk about, which is using even topology, even polygon distribution, and why it's important. So, polygons subdivide. We subdivide polygons all the time for things like subdivision modeling, for making stuff in ZBrush, for baking things out from a high poly source to a low poly. And there are lots of ways to lay out polygons. Obviously, there's an infinite number of ways. However, there are some best practices you want to keep in mind when you are modeling characters, especially characters like this guy right here, who have very organic shapes and who you'll probably want to sculpt on a little bit. I have a pretty rough base right here that I just made in ZBrush with some Z-spheres and Z-remesher. It's good. It's good. It's okay for sculpting, but it's not perfect. It's not able to achieve the kind of detail that I want it to, because the topology just doesn't lend itself to adding details to the right areas. For example, the areas around the eyes right now, you can see are not very dense. So the loop going around the eye, sort of in this general area, and anything inside that loop, well, there's just not enough density to capture the level of detail that I want to go for. Because eventually I do want to sculpt things like, bags under his eyes, or detailed eyelids, stuff along those lines. There are also other areas, like the tip of his nose, where, it's serviceable, but there isn't a lot of detail there. Certainly not enough to support the general shapes that dogs, wolves, any sort of canine might have in the nose area. So this is a problem. And this is where polygon distribution comes in, and this is where you can make a choice as a character artist to put more detail into those areas so that the result ends up being a lot more clean and something that you can control a lot better. So let's talk about some ways that we can do that, and let's also talk about some areas where you might want to have less detail, or you might want to just have, say, a simple grid laying over the top of something. For example, there's just a simple grid on the top of his shoulder. That's perfectly serviceable because the top of his shoulder is just pretty round. However, that little grid right there for the tip of his nose just isn't working. It doesn't have the details to support what we need. So let's talk about some areas where having that simple grid is just fine. It's just perfect. Specifically, like I mentioned before, the top of his shoulder, that's a good place to have just a simple grid that you can just pump a bunch of detail into and smooth out if you want to in, say, ZBrush, or just by modeling that detail. If I take this guy and turn him into subdivision surfaces, this retopology, you can see that the top of that shoulder smooths out extremely well. It's a very smooth shape. It's very nice and clean. But there are other areas where that's not the effect that I'm going for, the nose being an example. However, other areas would be this loop going along the shape of the deltoid. I do want to have more detail in here. So a simple grid, like on the top of the shoulder, is not going to suffice. Additionally, areas that tend to deform a lot, such as elbows, knees, ankles, hips, these are all areas where you don't just want a simple grid, and you don't just want to, subdivide it a bunch until it sort of looks okay. These are areas where you want to specifically put more detail so that as you're doing your work, you can make sure that anybody who's rigging it is going to have an easy time getting all the correct deformation in there, And you're going to want that detail in there so that you can sculpt some of the more complex shapes, like the insertion of the bicep into the forearm. So packing detail into areas like this actually serves dual purpose. It's good for you for sculpting, but it's also good for the rigger who's going to come after you and actually make this guy able to move around. So yesterday, or rather Tuesday, during the last stream, I talked about this elbow that I have right here. This elbow is okay because it has more detail than the surrounding areas. For example, the bicep only has 1, 2 loops going around it, but the elbow itself has 4 loops going around it. That's, twice the detail just in the elbow. But this still isn't quite enough detail. Additionally, there are some areas like the bicep where, even though usually it's a fairly smooth shape, there are some things you might want to do to detail it. And this is where, once again, having fairly regular, evenly distributed topology sort of comes into play. For example, I might want to sculpt a vein going along the bicep and into the forearm, much like you'd see on, say, a weightlifter, some sort of bodybuilder or something along those lines. And in this case, I want to have more detail than I have right now. Because even though when I subdivide this, it adds a lot more detail, it's not even detail. As you can see, when I subdivide it, these polygons never get square, so when I go to sculpt this, there's always going to be some odd stretching. So let me show you a better example. Let's just go to ZBrush and make a simple cylinder. Let's turn off the red wax because that's ugly as hell. And so here we have a simple cylinder, and let's just stretch this so that it's a lot like the bicep. Oopsie daisy. Just stretch it vertically. Oop. Oh, it would help if this was actually a polymesh, wouldn't it? There we go. So let's just stretch this vertically so that it sort of matches what we have back over in Modo. And now let's try sculpting on this. So you can see that I have those long stretched polygons, sort of like I had on the bicep. And in a second, you'll be able to see why this causes problems for when you're sculpting. So let's just subdivide this a bit. And now let's try sculpting just a sort of vein along here. Now, as you can see, along one axis, you get a nice amount of detail. It's very rounded. And this comes from the fact that in cross-section, this cylinder has lots of polygons. However, up and down, it doesn't have as many. The polygons are long and thin, so you're not getting as much, detail vertically as you do horizontally. This is a problem, and it means that if you have a structure like this, you're going to have to end up using a lot more subdivisions to get the same amount of detail. Now, by contrast, if we go back to when this guy was just a chunky little fat sphere, or cylinder with fairly regular topology, and we go and we subdivide this, even as we step down in subdivisions, you can see that the distribution of detail is fairly consistent across the board, both up and down. You can see that side to side and up and down, it has a very consistent level of detail. Now this is something that we want. This is something that makes it easier to sculpt, and it's something that makes it easier for a rigger to do their job. Having this consistency is good both for sculpting and for rigging. And consistency is a huge part of being able to do good work. So in the case of this guy, we want his topology to be very consistent so that he is easy for both us, the 3D modelers, and the riggers who we work with. So in this case, what we'll want to do is either put a cut, say starting here and going around like that. Oops. Let's actually, there we go. So maybe put a cut like that, or, and this is probably just a better, easier solution that'll lead to better topology, or we can just do something like this, where we select these and just add a few more loops. So we'll just do that real quick. So you can see this already is starting to look like some nice even squares, but this right here is still stretched, so that's going to cause us some problems. So let's add a few more loops in there. And let's, oh, looks like we had an ingon in there, so let's just clean that up real quick. I'll just cut across here. Now, let's make sure that these long stretched rectangles are turned closer to being squares. There we go. That's good. Now, you will notice that there are still some areas, like on the top of the arm right here, where you do have some fairly stretched stuff going on, but in comparison to what's around it, it's actually much denser. So even though these are fairly stretched in here, you're not going to notice as much as you would if those stretched polygons are along here. This is the much larger plane. This is where you're going to be doing a lot of sculpting as opposed to just a little bit of shapes. So it's okay to have some stuff like that. But in general, the rest of this arm looks pretty good. So let's go through some other areas of this model, even things out a bit, and just generally make sure that he's going to be easy to sculpt on and easy to easy to rig. So we've got a lot of areas where there was inconsistent polygons. So let's just take care of some of those. Now in the middle of say some area that doesn't have a lot of deformation, for example, this part of his foot where it leads up into the ankle, this area is not going to deform much, and we're not going to be sculpting on there very much. So it's kind of okay to have longer, thinner polygons, but if we wanted to add some more detail, we pretty easily could, simply by just cutting across there. So let's even out some of the detail and just smooth things out in general. And then we'll start talking about where it's appropriate to start using things like ingons. So here's an area where the level of detail is pretty inconsistent. And this one we can actually solve by not adding more loops, but just by moving some. You can see that as we move these up farther, in general, the layout gets a little more even, a little easier to look at, and a little easier to work with. Just move these up. There we go. This is already looking a little better. We can move this up into here, so it starts to approach being a square a little more. There we go. We can move these down a little bit, even out what's down here. Now, it's okay for there to be some areas where things are packed really tightly together, like here in the crotch, because this is one of those areas that's actually going to be deforming a lot, and having lots of loops next to each other, like this, is actually going to make it a little bit easier for a rigger to get this specific area to deform in an attractive way, simply because this is an area that, one, people don't look at a lot, and two, needs to be able to sort of stretch perpendicular to these polygons. So this is looking pretty okay. We don't need to adjust this very much, and because it's such a tight area, we don't need to worry about sculpting as much detail in there or anything like that. People aren't going to see it very much. So that's one area where we can kind of get away with it. So that's looking a little bit better. But there's still some problem areas, like on the middle of his thigh right here. You can see that there's these two big loops right here. It's just kind of inconsistent with what's around it. So let's do something here. Let's actually just get rid of some of these loops and add a few more in and just do it very regularly. Let's do, oh, that looks pretty good. It's nice and even. We can do the same with this one right here. We can add, say, 2 more. There we go. That's pretty good. We'll do the same on his abdomen, general torso. Let's see here. You know what? This right here is a good supporting loop because what it does is it changes the silhouette nicely. It goes into one of the deep areas and then leads out to the outermost areas. So we'll leave that one there, but we'll get rid of this one. And then for these two, going across like that, we're going to split them up. Add a little bit more density in here because this is one area that deforms a lot when this guy, you know, runs around or bends forward or back, generally moves his torso around. Alrighty. Now here you can see there's another loop which is kind of providing us with some issues. And we have an n-gon right there. That's not a great place for an n-gon, so let's move it up a little bit into an area where when we subdivide it, that n-gon will actually provide some better support. Even these things out a bit, and then add a couple more loops in here. There, that's a little better. Now we still have this area in here, which is pretty stretched. There is some stuff that we can do to even that out for now, but I'm not going to worry about it too much. There's a lot of stuff that's going on in this area. There will be a lot of secondary movement, especially with this tail, so we might not necessarily need to worry about this area. However, if this ends up being a problem, and I will talk to the person who's going to rig this about that area, if it ends up being a problem, it can be adjusted. We can do some stuff in here, like we can move this up, bridge these to make that even, and bridge these, and then in this area we can have a loop going down like that. Or we could have a loop that goes like this and then has this coming up like that. Then we can move this down. Move that to be more even. Move this out a little bit. And things are starting to look a little more even and just generally better. So there are some options for areas like that. Now, where's an area where it would make sense? Oh, we've got a question in chat. Is there any worry of polygons crushing in on themselves when they're so close like that? Oh, excuse me. I'm assuming you're talking about areas like this in the crotch where there are lots of them close together. It can be an issue when you have polygons very close together. However, for areas like the inside of the crotch, probably the inside of the elbow, areas like this right here where the leg will sort of rotate up and into the chest area, it can present some problems, but in general, it's actually good to have that sort of density because what it allows you to do is account for some of that weird crushing in with things like blend shapes, good skinning, just general workflows that incorporate pretty advanced skinning and animation features. It's okay to have some areas like this. You just don't want them to be everywhere. In general, those very tightly packed areas should be around joints, where you can make the most out of having lots of tightly packed polygons. So let's talk about n-gons a little bit. N-gons are super useful tools. I touched on them very briefly during the last stream, but I want to give a specific example of where they can be useful, especially when you're working using a workflow where you heavily take advantage of subdivision, subdividing your model like I've been doing. Um, when I subdivide this guy, this is probably the amount of detail that he's going to have in the final model. And there are certain shapes that it's difficult to get without taking advantage of triangles or n-gons. So here's an area, right here on the back of the foot, where I need some detail, but the problem with having more detail in this area is that I either need to put a cut through here, which then connects to the back, which might be either difficult or just kind of annoying to work with, or I need to just put a simple cut right through here. And what this is going to do, what having these n-gons right here is going to do, and having the cleaner topology right back here will do, is that when I subdivide this, when I'm going for the final version, those n-gons will all turn into quads, and they'll be joined together with this type of topology that supports what's underneath it. And obviously, when I subdivide, it converts everything to quads, so I don't need to worry about it being difficult to skin or providing problematic areas for sculpting. It's an area where it automatically puts some good detail in there that otherwise I might not have. By that same token, right here on the back of the foot or the leg, and here on this part of the shin, if I subdivide this while it has an n-gon, it just closes off that n-gon with this type of shape and makes it very easy to work with. Now, other areas where you might not want to use n-gons would be in areas like this. This right here is going to be the little socket for a dew claw, which is just a small claw on an animal's upper foot area. You see them on mostly on dogs, but other types of animals have similar things going on as well. And I could have a little n-gon in here, which would subdivide pretty okay, but having it so that it's actually split up into two quads is a little bit better. So here's what it looks like when it starts off as an n-gon, and then I subdivide it. It turns into this shape that has a bunch of quads in here, which, having quads is good, but the problem is that when these quads, or when a similar layout of quads is imported into an engine, they'll be converted into triangles, just like any other polygon would be, but it's difficult to predict how they're going to triangulate. So if you just select this, and if you triangulate it, you might end up with a shape like this, or you might end up with all of these facing the other way. And it's difficult to predict how it's going to triangulate, especially if you're talking about something where it's auto-triangulating once it's imported into an engine. And things like Unity and Unreal 4 and CryEngine, they will have different methods for triangulating those types of shapes. However, if I turn this into two quads, like so, what's going to happen is instead of it being a pole with like 8 sides going in there and a bunch of difficult topology to work with, instead it ends up looking like this. It's a very clean shape that is very predictable, that is just quads. There is no intersection of quads that it's greater than 4 of them coming together. That's very good for sculpting, and it's also easier to predict how it's going to shade and triangulate an engine, because you don't have either long thin triangles or short squat ones. You always know what that type of shape is going to look like. And this is actually one of the main reasons that I like to use loops of polygons in, say, numbers of, 4 or 8 or 16 or 32, because it always provides that type of very predictable result. Now we have another question in chat. This one is the auto quad that results from subdivision specific to Modo, or is it something that is in basically any 3D package? And I believe, and I may be corrected on this by someone else who knows a little better, but as far as I know, and according to all my experience, most, if not all, programs that can subdivide like this should always subdivide into quads. Now, the way that they subdivide into quads might look slightly different. For example, with this ingon right here and these two quads right here, the result might look slightly different than this, but as far as I know, the algorithm that is used in general for creating subdivision surfaces is always going to result in ingons turning into quads. Now, I'd love to be proven wrong, and if you have a counterexample, I'd love to see it. I know that there are a couple of instances where if you have a very large ingon that's, say, a circle that does not have any sort of support loops going through the center of it. So, for example, if I just make a cylinder right here, let's just go here. This, depending upon the program that you're using, might subdivide in different ways, but that's really the only type of case that I'm aware of where it might spit out triangles. And yes, it'd be useful to test that out in Max, Maya, whatever program you're using, just to make sure that you know exactly what you're running up against. So let's get back to this ingon that we were talking about earlier. This guy right here is kind of a problem. And here's why. Let's put this guy back to sort of the general area where he was. He was an ingon that was terminating right here. This loop right here was terminating at a quad, turning it into a 5-sided polygon. Now, that's okay. We've sort of demonstrated that that's okay on his legs, on his feet. But it's not necessarily okay for right here. So when we subdivide this, you can see that it does the same pretty predictable behavior that we had before. It has this sort of layout. However, this is a bad place to have this sort of polygon layout because, well, because of a number of reasons. But in general, it's bad to have intersections of, say, 5, 6 more polygons in an area that deforms a lot, because it's very difficult to control how the skinning is smoothed across those polygons. If you have 4 polygons, you can very easily control the gradient from 100% influenced by a bone to 0% influenced by a bone by just doing a simple gradient across these 4 polygons. However, you can't get the same type of gradient across all 5 of these because you don't have just a sort of, 1, 2, 1, 2. You have a 1, 2, a 1, 2, but then a weird third child in the middle. So that provides some problems. So that is actually why I pushed this loop up to an area that's going to deform less. This area at the bottom of his rib cage, it's okay if it has this sort of intersection, because 1, that actually supports the shape of the rib cage, and 2, the rib cage, aside from maybe a small bit of twist or bend in this area, isn't going to be moving around as much as the top of the thigh will. So it's okay to terminate into an n-gon right there, or perhaps even farther up. All right, so now that we have, now that we've discussed a little bit of how n-gons can work for you or not work for you, Let's talk about capping this tail, because this is actually one of those areas where you can run into some problems if you don't know how to set up the topology specifically for capping a cylinder. Now, capping cylinders is something that you're going to run into a lot in cases where you're doing things like, for example, tails, but also things like fingers, teeth, claws, even pointy ears like this guy has. Um, if this guy only had one hand, if one hand had been removed and you needed to cap off the cylinder of his arm, you would need to have the right topology to do it so that it doesn't shade badly and so that you can perhaps attach other things to it. And especially if you want to sculpt it and make it nice and smooth. So let's cap off his tail and talk about some different ways that you can do it, and then I'll talk about the way that I prefer to do it and why I prefer to do it. So there are a couple ways that you can do this. The first one is to obviously just take all these points, make a simple polygon out of them, and there you go. There's a little cap on his tail. It's done-ish. You will run into problems if you want to subdivide this, though, because you start getting bizarre shapes like this. But that, maybe that'll look different if I mirror this over. So let's, there's always going to be some weird stuff going on along the center line if it's not completely mirrored over. So let's mirror this over and see what that looks like. I'm just going to collapse this down a little bit. And then mirror it. Okay. Alright, so he's all mirrored, and it mirrored that big ingon as well. Let's subdivide this guy, kind of like we maybe want to sculpt him. And, oh dear, okay, let's take a look at this. Let's take a look at what it looks like when it's not trying to snap to the high poly. Oof. Oof. Oh, that's not good. So clearly we're having some problems here. Basically what it's doing is it's trying to convert these two big ingons into quads, just like it did with, say, the ones down here on his foot. But it doesn't really know the best way to do it. So it's trying, but it's not really succeeding. So what else can we do in this situation? Well, we could try merging these into one big ingon, and what that'll do is something like this. But we already talked about capping things off with big ingons like this. It, shoots a bunch of lines through the middle and makes it hard to deal with. Okay, let's try beveling this. If we bevel this, we can get some more detail out of it, and it just does the same thing. Okay, so we need a better solution, and there is a better solution. There are technically two solutions that you could use that, in this case, would be pretty excusable. However, one of them just ends up looking like the ingons that we just had. So, solution one, which you will see pretty often on fairly low poly models because they're not the ones that are being sculpted on. Solution one, let's go here and just do this. Okay, so we turn it into a spike. Spike goes at the end of his tail. Done. This is okay, but just like when we created all those ingons, it doesn't end up being very sculptable. You have this big point right in the center where you're simply not going to be able to sculpt on that. And if the tip of his tail needs to have some, cute little twitches or something, that's simply not going to work. It will not read well. It's going to be ugly. Nobody will like you, especially not the person rigging it. So there is another solution. Now, I mentioned before, several times, that I like to work in loops that are multiples of 2. So 2, 4, 8, 16. Now his tail, right now, because I started from a 4-sided cylinder, is now that I've subdivided it a little bit, it has 16 edges. Oh, and we had a little question in chat: is would that spike be a problem since I've already sculpted this character? This is a mesh for a bake, right? Sort of, kind of, yes and no. There are multiple parts to the answer for that question. So, part one is that yes, technically I've sculpted this character already. However, I'm not very happy with the result that came out of ZBrush just from Z-remeshing. There's a lot of detail that I wasn't able to achieve, like I mentioned before, with these areas around the eyes and the tip of the nose. So what I'm doing is I'm building a mesh that I can use both for a sculpt and for the low poly later on by just removing some polygons. So technically, no, it wouldn't necessarily matter if the tip of his tail was just one big spike. However, I don't want the tip of his tail to look like a spike. I want it to have sort of a rounder silhouette like you see in the high poly right here. I want to catch some of that rounder shape. Ooh, excuse me. So one way that I can do that is by taking advantage of the fact that his tail has sides that are a multiple of 2. They're a square of 2. There's 16 around. What that means is I can start with a square and subdivide the square and connect that to this tail. So let's talk about how I can do that. Let's give an actual example. So I'm going to take and just draw a square right along here. I will, let's see here. Let's just do a square. Ooh, we've got some snapping issues going on. There we go. Okay. So there's just a simple square. All right, that's peachy keen. That's not really useful for me right at the moment, though. So let's move it into the right position where it is going to be useful. And that position is right on the tip of his tail, because what I'm going to do is I'm going to make something on the tip of his tail and then connect it to this loop. So, now like I mentioned before, when I was making his arms and legs out of those 4-sided cylinders, I want some points and some loops that go along the center lines. So I have center lines right here and right here. And then if I come to the middle, I've got one, I think, right there. Is that correct? 1, 2, 3, 4. Yep. So there's a center line on that side. And then I have a corresponding one over there. So I want points or loops that match where those center lines are. So instead of just doing a very simple square, I'm actually going to do a diamond shape. And that diamond shape is going to look like this. Let's center these. And, ooh, not sure why that's flipped around, but now let's just mirror that so we have a nice simple diamond. Turn it into one polygon. Okay, so I have right here, this little square right here, this is the basis for, I mean, it could, you know what, let's just delete the rest of his tail. We can do that. We can do that right now. We're going to make his entire tail just from this little square pretty quickly and easily just by extruding some edges from it. And it's going to match up perfectly with these loops right here because it's going to have the same number of sides. So we'll just start this off. Alright, let's connect these suckers. So here's the center line for the side. Let's move this to the center line for the bottom. Move this to the center line for the top. Make sure that everything's nice and evenly laid out. Alright, cool. Let's add some more. We're continuing this center line. This right here is the line along which we're going to mirror things. So let's just get that right to the center. Put this along the actual center along the side, so we're probably going to move this down to there, and this to here. Oop-a-doo. There's that center line again. Oops. All right. So this polygon right here is actually going to connect to 4 of them up here. So let's make sure that we have this along the center. We're going to do the same down here. And this is the method that I use for basically any humanoid topology. It's this very simple set of cylinders based on things that have 4, 8, 16, 32 sides. And since I always use the same numbers for each limb, each anything, that translates into me being able to do things like swap parts between different models. So, for example, I was actually working on a different model version of this model the other day, and I didn't want to have to go and rebuild his feet from the ground up. No pun intended, I suppose. So I just grabbed those and copied and pasted them over here. And because I use loops with 16 sides, I was able to just connect it really easily and quickly, and had absolutely no problems with it. And as long as you use very consistent numbers for your topology, you can do the same thing with just about anything. So that's what I'm doing right here with this tail. So let's delete that, mirror this over, make sure that that's all one piece. Nope, we need to weld those. Oh my goodness. Weld those together. Looks like everything else is welded. Okay, cool. So let's make sure that is a quad. We're going to add a couple more loops in here so that we have nice even topology, which is some big squares. So that looks pretty okay. We'll move these so we have a nice smooth curve. And we're going to be re-mirroring this and such a little later anyway, so it's not super important if it's completely symmetrical right now. We just want to make sure these are along the center line. Alright. Now, little square, little diamond friend, it's time for you to do your magic. So if we subdivide that, we get a couple things. We get a nice center line that will connect to this center line. We get center lines along the sides that connect to those center lines, along the bottom, and from the side, this guy right here provides a nice rounded silhouette that you wouldn't be able to get with just a simple spike. Additionally, it's going to shade a lot better than a simple spike. And finally, there are some fun things that you can do with 8-sided polygons and such in here to cap things off. You know, I could rotate the center lines along here so that things connect a little better. There's really a lot that I can do just in here with some simple quads. So let's do one more subdivision. Because this has 8 sides, if I subdivide it one more time, I can then bridge this gap. And it's already pretty even. Now there's some weirdness where this isn't completely along the center line. We can fix that. So we'll just do that 0, center it. Do the same thing up here. Center it. And that's pretty okay. Now we can, if we want it to be a really smooth transition, we can remove some of those and then start adding in some more loops again. That's looking pretty all right. And now if you want to say have a nice center line going along here, something that's really easy to do is just take this, cut it, paste it, rotate it 45 degrees. And then bridge it again. And now you have a center line going along the same way. Now you could have started out as not a diamond shape up here. You could have started out as a quad that just looks essentially like that. And it would have drawn lines in different ways, but it would still be usable. I just find it very easy to lay out the center lines by using a diamond shape. But your mileage may vary. You know what, this is a little too dense for my taste, so let's just get rid of some of the edges. That's not dense enough. There we go, that's good. Alrighty, so from this point on in the stream, I'm mostly just going to be focusing on getting some of the topology for this guy finalized. There are a couple of other small areas that I just want to adjust or tweak, but I'm really not going to be providing too much commentary from this point on, because I've covered the most important aspects of what I wanted to talk about tonight. So really from this point on, over the next hour or so, I'm free to take questions from the Twitch chat if you have something you want to talk about or ask about. And then after that hour is up, I'm going to hop into the private hangout with the program members. So if you missed my spiel before, I just wanted to reiterate that this this series of live streams that I'm doing is part of a workshop that you can sign up for if you like, where essentially what you get is these live streams, and then for an hour afterwards, in a private Google Hangout with other program members, we'll be talking about all kinds of things, from modeling to baking to UVs, general questions about the game industry, really any number of things that are related to what I do as my job, what you do for your job, or what you might want to do if you are not yet in the industry. And it's sort of a space where you can get group feedback and even portfolio feedback or reviews. It's a pretty open discussion throughout the entire thing, and that happens twice a week, just like these streams do, and it's an hour-long private discussion. During the last one, I talked to a couple of the program members about some of the content from the stream, and we also did a bit of a group critique on one of the program members' models that he's working on. We had a look at it. I gave some feedback. Some other people gave feedback, and it was pretty productive. And I think that everybody sort of learned some stuff, and everybody had a great time, looking at the work that other people are doing. So, if that sounds interesting, if you want to be part of that, I still have some slots open for the workshop. So, go take a look at the Patreon thing that I have set up. It's under the same username, just on Patreon, and see if it's something you'd like to do. So now I'm just going to keep on modeling. Let's see here. So we've got a couple more questions, one of which is, will you cover how to cut hard edges into curved surfaces at some point? If not here, I can ask in the private hangout later. Like a triangle cut into a cuff or the bottom of some pants. Yes, I'm going to be talking about cutting harder shapes into more organic ones. I'm actually going to be talking about hard surface modeling and clothing modeling for character artists later on in this workshop, and some of the challenges you might run into. I'm also going to be talking a little bit about retopologizing clothing and such, though I'm not going to get too deep into it because it is a pretty big subject, just because there are so many things that go into it. However, yes, I will certainly talk about using things like booleans for organic shapes, doing hard surface modeling, clothing modeling, retopology for clothing, and what that entails. Taking clothing and putting it into ZBrush, that type of thing. I'm only going to be briefly covering it, but at least for this character, it's not super important to cover that type of thing anyway. And it's actually something that really could be an entire workshop on its own. So that's another reason why I'm only going to be covering it briefly. But if there are enough questions regarding that type of thing, sure, I'll talk about it some more. Another question is for this creature's nails and for his claws and the nails on his feet, are they always separate from the main body? For this specific example, yes, I am doing them separately from the main body, simply because that's going to allow me to get some better topology flow on areas like his fingers. It's also going to allow me to do some very easy UV and material separation between the main body and the fingernails and such. Specifically by actually having the model split off there rather than just baking them all as one shape. There are a couple ways to do it, but the reason that I am doing them as separate pieces is so that it'll be easier to give them independent movement. That is, movement that's independent from the rest of the fingers or toes. I believe one of the people I work with wants to rig this character, and it might end up being that someone else wants to animate it. So I'm trying to give them options for adding secondary motion for the claws. If the claws, bounce off the floor or something like that, I just want that option there. And if they end up not taking advantage of it, at least the option was there. And once I release this model to the program members, they'll have the option, if they want to animate it, of animating stuff like this. And that's actually another thing. At the end of every week, I'm actually going to be releasing the materials that I use on the stream, whether it's something I've made or models that I'm using as a base, anything like that. I'm going to be giving those out to the people who sign up for the program so that they can take a look at either my work or the work of, people whose work I use as reference, that type of thing. So for example, once this stream is done, I'm actually going to be taking this model that I'm working on right now and exporting it so that anybody who signed up for the program can download it and then use it for their personal learning process. And by the end of this program, this guy should be ready for texturing and animation, and that'll be a good reference point for anybody who signed up. They can take a look at what I did, take a look at how I did the UVs and the, any topology that isn't necessarily obvious on the stream when I'm modeling him, and then they can use that as an example in their own work. I've got another question in chat. This one is, do you typically use ZRemesher as a starting point for your in-game resolution models? That's kind of a tricky question, but I would say that in general, no, I don't. The general reason being that ZRemesher, while it's okay for sculpting because it often provides a very evenly spaced or very evenly spaced topology for the model in ZBrush, it doesn't provide very clean topology. So let's take a look at this high poly model to get a good example of what I'm talking about. So as you can see here, just from a distance, this model has, this is straight from ZBrush. This was Z-remesher. So I did Dynamesh and then Z-remesher, and it's super even. It's very it has a very even layout that is pretty decent for sculpting, at least larger forms. However, it does have some problems, and some problems that I can't really fix in ZBrush, and that will not allow me to get good results in a low poly model by optimizing it. So specifically, there are things that I simply can't control, like the resolution of the polygons around the eyes here is just, it's bad. It is not enough resolution in that area for me to sculpt a detailed eye or eye region without going to absurdly high levels of subdivision. So this right here is already, this is the lowest subdivision for this Z-remesher model, and it's 205,000 triangles. That's, that's okay for sculpting, but it's going to be a pain to optimize that. And if I subdivide it, it's going to multiply the number of polygons by 4 every single time that I subdivide, and I may not need that type of detail elsewhere, like on his bicep or in the middle of his thigh, but I would need that kind of detail on his eye. So when I get to retopologizing his face, I'm going to intentionally put more detail in the eye area and in the nose and some other places, so that I can intentionally sculpt those areas at higher detail. That's an area where Z-remesher is not very good, and it's also Z-remesher also makes it difficult to optimize for low poly models by doing stuff like this, where you have weird triangle terminations of loops, and this type of thing right here, where the loop, it kind of curves around oddly in the middle of a large smooth form. If I select this loop goes all kinds of crazy places. And I've also got stuff right along the center line where this should have a line going through it if I want it to be completely symmetrical, but it doesn't. So if I am going to make a low poly model, or a high poly model that is then going to be turned into a low poly model, I generally don't use Z-remesher for any part of that process, because I like to be able to control the number of, say, polygons that are around his wrist. So there are 66 polygons around his wrist. That's kind of a strange number to work with. And if I try to do something like select a bunch of edges, and then remove them, well, it's going to take a little while. But I'm not sure what exactly the result will be every single time. Whereas if I do things the way that I usually do, with always having 8 or 16 or 32 sides on like a wrist or something, I'm always going to know how many polygons I can get away with removing, and it's always going to be very predictable. So there's another question. When it comes to hiring character artists for AAA games, does not having previous AAA experience disqualify you, or do you invest in employees based on talent and potential? That's a very good question. I think that's the answer for that is going to vary depending upon the project that the person is applying for, the specific company, the people doing the hiring, and what type of person they need for the given project. So, for example, I'm working on Spider-Man for the PS4 right now, And, we hire all kinds of people to do all kinds of different jobs. And in certain cases, we essentially need a warm body to put in a seat to do a thing right now because it's an emergency, and we know that even if they're not super experienced, they will be able to just get the job done. In other cases, you can afford to be a little more picky. For example, if somebody just decides that they're going to leave the company because, they want to pursue other interests or something, no hard feelings, whatever, but then you need to go and replace that person, and it's not in the middle of crunch or something, that's one case where you can afford to essentially shop around a bit. In that case, it's a buyer's market, if you will. Even though we might want somebody who is super experienced, maybe somebody super experienced isn't currently looking, or maybe if we want to not have somebody super experienced because our team already has lots of experienced people, we'll go looking for somebody who has less experience, but who shows that they're capable of doing good work if they have enough time. In that case, it might be a question of interviewing them and seeing how they fit with the team, and then training them on the job. There are a lot of factors that go into it. I don't think I've ever heard of any example of a company that absolutely requires AAA experience that's working on a AAA game, because most of those companies, unless they need somebody immediately who is experienced without having to, ramp them up and get them into production slowly, I don't think I've heard of any companies that will absolutely require that type of experience. So I would say that if you're looking to start a job at a AAA developer and you don't have any AAA experience, that's not necessarily a bad thing, and you should still apply if it seems like the job is a good fit for you. And that really goes for any developer that you're thinking of applying to. If you think that you would be a good fit for the job, you should apply. Even if it's something that's kind of outside your previous experience, go ahead and apply, and the worst that can happen is they say no. The best that can happen is they hire you. They might hire you on a trial basis, or they might hire you, say, as a junior or something like that, but, nothing ventured, nothing gained, essentially. So if you're not certain if they require experience, just go for it. So we have another comment in chat about the sort of nails and claws that this guy is going to have. He's going to have some big sort of sickle-like claws on his hands and then some smaller nails on his toes. Actually open up the high poly for this guy real quick. 1 second. And I'm going to just give an example of where I could, or maybe not necessarily should, do different meshes for things like claws and nails. So let's open that guy up real quick. This is going to take just a second, so I'll take a sip of my wine. Here we go. So you can see right here that the high poly for this guy, or at least the current iteration of the high poly, has these big chunky nails. So I want to have the person who's animating this have the ability to rotate those claws somewhat independently of the rest of the finger. And I want the person who's going to rig it to be able to put an extra bone in there if they want to make it so that it can move independently of the rest of the hand. Because honestly, I just think that it'd look cool. It's also going to make it easier for me to texture with these separate claws, both bake and texture, because what it's going to do is it's going to allow me to bake him as separate chunks. So like a chunk for his claws and his teeth and his little nails on his feet, and then a big chunk for his body. and I won't have to worry about splitting it up into different baking groups or anything like that. I can just dump the separate models into the baker and not worry about any sort of weird intersections. Having those claws separate just sort of serves a dual purpose, and I don't really need to worry too much about the polygon budget. One, because this is just personal work, but two, because adding the additional, how many polygons do we have here? So we've got, let's see, that's 8, and then so there's 12, 24. So this right here is 24 triangles. If I subdivide it, that's going to be 48 times 2. It's going to be, what, 90, 92, 96? 90 something. That's going to be, over the entire model, that's going to be maybe 300 triangles, which honestly is not going to make any sort of difference. Triangles are cheap. Materials and textures, video, uncompressed animations, those are the things that are really expensive and the things that take up lots of space on say, a Blu-ray disc, or are very processor intensive. Doing things like adding blend shapes, that's where things start to get expensive character-wise. But adding a few more triangles really isn't going to make that much difference, especially on hardware like a modern PC or a PlayStation 4 or an Xbox One, something like that, because modern PCs, modern consoles, they can push literally millions of triangles on screen at any given time with little or no slowdown, and they routinely do. So, whenever you are, say, I don't know, playing Battlefield or something, you're going to have hundreds of thousands of triangles on screen at any given time, whether it's from the first-person view models or from the other models that are drawing in the distance, the other player characters, or any number of other things. And really, just drawing some polygons is cheap. Drawing polygons is super cheap because the hardware has been optimized, super, super, super optimized to draw all those polygons. But they're also just generally cheap because really they're just some points in space that are connected by planes. It's what you put onto those polygons that slows things down. So if I have 500,000 triangle character model that I'm trying to load in game, it's going to load up just fine. But if I have a 300 triangle character model that uses 4K textures and very high quality rendering with lots of post effects and lots of maybe particles swirling around, very heavy animations that are uncompressed, that's when you're going to start running into performance problems, even if it is a very low quality model. So, for example, on Spider-Man, we have very high polygon budgets simply because we don't really need to worry about the number of polygons. And that's sort of the case for most modern video games, too. You just don't need to worry about the number of polygons so much because really they're the thing you need to worry about the least. Really what you need to worry about is those shaders and post effects. Also, speaking of shaders and post effects, if you're interested in that type of thing and you're not really familiar with them, I did do another similar workshop and I posted all the videos on YouTube, similar to how I'm doing the YouTube postings for this workshop. So if you want to go and check that stuff out, you can go and watch it right now. It's all up there. There's something like 16 hours of content of me just talking about materials, giving examples, making textures, editing textures, making materials, doing lots of rendering. If that sounds cool, you can just go and watch it. There are no ads on it or anything like that. It's just some videos you can watch. I had a lot of fun doing it. I'm probably going to do a similar one in the future. And yeah, I got a lot out of it, and it seemed like the people who signed up for the mentorship or the workshop rather, they got a lot out of it too. So if you're into that kind of thing or you don't know much about that kind of thing, go and give it a watch. I also give lots of different examples of places you can go to get more information about things like physically based rendering and that type of thing. So if that floats your boat, go and check it out. Meanwhile, I'm just going to keep noodling with this model and waiting for more questions in Twitch. For about, maybe 45 more minutes. And then once that 45 minutes is up, I'm going to jump into the private hangout with the people who signed up for the workshop. Got another question in chat about my next workshop, asking what the next topic is going to be about. And, well, honestly, I haven't decided yet. I know that the materials and rendering course was pretty successful. A lot of people liked it. A lot of people tuned in to watch it, and a lot of people signed up for it. And I'll probably cover something along those lines, but I haven't quite decided yet. That one was sort of a reaction to people having a difficult time getting good rendering results. So, I don't know. I mean, this one has been sort of a reaction to people having a difficult time with things like retopology. So, I'm just trying to cover the topics that lots of people seem to be interested in at the moment. So, we'll find out, I suppose. I'm not sure what the next one's going to be about, but hopefully I can come up with a pretty good topic that'll interest a lot of people. So someone's asking if I'm planning to put this wolf guy into any particular engine, such as Unreal 4. I don't really have any particular plans to put it into an engine, per se. I'm definitely going to be rendering the final result in Marmoset Toolbag, just because that's sort of one of my preferred tools. I might end up releasing the final model for free, but I couldn't really say about putting it into a real-time engine like UE4 or Unity or anything like that. Someone else is asking what kind of characters I'd recommend for someone who's trying to revamp their portfolio to target AAA or feature film animation. It's kind of a frustrating answer, but I would say it depends. Mainly because AAA it's a pretty broad term. When I talk about AAA for this course, this workshop, it's more in the sense of things like polygon budgets, certain modern rigging and animation things to keep in mind, and that's the sense that I use it in. But AAA covers a lot of different ground. Technically, Mario that's a AAA game. Just about any Mario title out there is a AAA game. It's got a huge development team and a lot of money being thrown around for it, but it might not have the same type of, say, texture or poly count restrictions that you'd run into on something like, I don't know, Modern Warfare or like Battlefield or something like that. That in mind, though, I would recommend that if there is a specific type of game that you're interested in working on that happens to be something produced at the sort of multi-million-dollar AAA level, that the characters in your portfolio reflect that. The characters in my portfolio are the types of characters that I like to work on. They have some style, they have lots of, bright colors and fancy rendering effects and stuff, because that's the type of thing that I find appealing. And that's one of the things that sort of drew me to Insomniac and drew Insomniac to me. I like to focus a lot on rendering, and they have a big focus on rendering at Insomniac, so it was a pretty natural fit. If you want to work on something that's, a realistic military shooter, you should go and make realistic military characters. Show the companies that are making those characters that you can actually do the work. Show whoever it is that you want to apply to that you can do the work that they're going to ask you to do, and you're going to be able to do it with no problem. There's always going to be a learning curve whenever you start at a new place, just simply because everybody uses slightly different tools. But all the concepts carry over, especially if it's, say, a specific style. You can hit specific styles using any number of different tools, so they're less concerned about the tools you use and more about the style that you actually are able to hit. So do I mostly turn loops like that when it's needed for deformation, or is it more to retain mass? So in the case of this loop along here, or these things around here, I'm mostly adding more detail so that I can retain some mass in certain areas. So like I mentioned last time on my sorry, like I mentioned during the last session, areas like this um, provide some challenges for modeling because while you might want to make the whole thing just a simple tube, having stuff that follows the actual contours gives you much better results when it comes time to bake or do texturing, that type of thing. So it's better to not have things that stretch across large gaps. It's better to try to get the topology to conform to the shape as close as possible, as long as it's not going to provide problems for deformation. So in the case of this underarm area, I did I did change the flow down here so that it would follow this muscle group a lot better. So it we have this loop right in here that follows that dip. Someone else is asking if I'll ever be a guest on Gavin's Character Art podcast. I honestly have no idea. I see him every day. I work with him. He's a cool guy, but I don't know if I have something that I could add to his podcast in the same way that a lot of other people have. Most of the people that he and John and Lena have on their podcast are generally more seasoned vets who have, say, 8 or 10 years of experience or more. I've been in the industry for about 6 years, but aside from being able to, teach things like topology and stuff like that, I'm not sure that I have as much to add as some of the other folks do with their sort of practical experience. So maybe, possibly in the future, but it's a very unsure thing. I haven't really asked about it, and neither has he, so I don't know. Just in case you're unfamiliar with what we're talking about, the lead character artist at Insomniac, my boss, Gavin Goulden, he is an artist who's been in the industry for a good 10 or 15 years now, and he and John Troy Nickel, along with Lena Lazar, they have a character art podcast in which they interview, well, character artists in the game industry about their experiences and, basically who they are and what they do. And it's pretty cool. You should check it out on YouTube if you haven't seen it before. It's pretty neat. So one question I'm getting right now is, how is a typical day at my job? Um, I assume that means like what is the sort of structure of being a character artist, um, and not, how do you like your job? Because I do like my job. I like my job a lot, which is why I continue to do it. But the general, um, I guess, daily routine of being a character artist, oops, is it's a lot like basically any other job. I go into work at 8:30, leave work at around 5:30, and be a vegetable on the couch for the rest of the night most of the time. Um, the a hmm, the work is more structured on a weekly basis than a daily basis, and basically what that means is that say on Monday I'll come into work, make sure that everything is basically just working out fine, that I don't have any sort of emergencies that I need to deal with, make sure that I don't have any bugs that have been assigned to me to fix, check my email, make sure that I have the latest version of all of our tools and the latest build of the game. What that allows me to do is make sure that I can edit files in our asset management programs with no problems. From there, I will, get all the latest files that I need to, start working on whatever model I've been assigned to do. Then in the afternoon on Mondays, we have an art team meeting at Insomniac where we basically just go over what happened the previous week, what's coming up in the current week, where we are on our current milestone, because we use a milestone system instead of something like Scrum or whatever. And then from there, it's back to work. On Wednesdays, we have the character team has a stand-up meeting in which everyone just walks around to everyone else's desk. People explain what they've been working on for the past week, what they're currently doing, and what they're going to be on to next. There are usually short critique sessions during that point. And then for most of the rest of the week, it's back to sort of business as usual with working on things, doing regular check-ins with, with my boss, with art directors, with people at the companies that we work with, and then it just sort of resets the next week. Generally, it takes between a month or two to finish off some of our main characters, just because getting feedback from companies like Marvel can be pretty time consuming just because they have a lot on their plate. But it's a pretty well polished process at this point. Someone else is asking, how did you learn about character art at the start of your career? Was it school, on-the-job training, or personal study? How did I learn the technical aspects of character art, like rendering and material creation, etc.? The path that I took towards character art was a bit of a weird one. I know a lot of people who went to school for, computer graphics, game design, that type of thing. I did not. I took several art classes, a lot of art classes, at the local community college for several years, off and on, but didn't have too much direction in my teenage years. My late teens and early 20s. I knew about things like making video games from having been exposed to things like Team Fortress 2, where they allowed you to make your own content. I learned about modding games from websites like Polycount, and I learned a lot about what goes into modding games by creating content for TF2 back in 2009 and 2010. I made some items during the first wave of user-generated content for Team Fortress 2, which were later integrated into the game and became sort of a, you know, staples of how it just all kind of worked out. Um, and then from there, I progressed on to working at a small local company, working on kind of a low budget MOBA. And I've always had sort of an interest in the technical side of things, so I naturally would start looking up how to do things like make materials, or what goes into lighting and rendering a model in a fairly technical sense. Those are just things that have always kind of interested me, and so I naturally sought out information on how to do them. So I'm essentially self-taught. I haven't really taken any classes related to 3D aside from one 3D Studio Max class where the teacher didn't actually know 3D Studio Max and he was just trying to teach from a series of handouts he'd found online. Um, but other than that, I'm essentially self-taught. Uh, Most of the information that I got was through contacts that I made online, looking at websites like Polycount, or even just like looking up terms on Wikipedia and then following the sort of online breadcrumb trail towards the right information. I don't really have any sort of formal training, I guess, so a lot of it has also been either on the job training or just investigating how stuff works in my own time. Someone else is asking what the hours are like at Insomniac. I can only really speak from personal experience because I I make a point of never staying late unless I absolutely have to, because I try to retain some semblance of work-life balance, even though right now I'm completely failing at that because I am at home at my computer doing an online workshop. But for me, at least, the hours are pretty good. They're very regular. I personally have not experienced any crunch in the almost 2 years that I've been there. And in general, they seem to be very good at time management. If you do hear stories about companies that have a lot of crunch time, especially mandatory crunch time, I would say that that's a pretty good sign that you shouldn't work there because it means that they are badly managing their time. Um, and you will get burnt out. Burnout is a real thing that happens to people, and it takes not just a psychological toll, but a physical toll as well. Because, well, I mean, honestly, they're not getting enough sleep, not having time to do leisure activities, not having time to rest and recharge your batteries, essentially, um, will lead to exhaustion. And so far, I've been lucky in most of my jobs in that only one of them had mandatory crunch time. But if you hear, for example, during an interview that the company you have applied to has mandatory crunch time at some points, you should run fast and run far and not look back because it's not worth your time. It is way more important that you are healthy and happy and able to produce good work than it is for you to burn yourself out. And honestly, if you start working in an environment where there is lots of crunch time and lots of late nights, you're going to get burnt out, and it's going to make you never want to work in video games again. And it's also going to make you produce worse work. You're going to produce stuff that's crap. If you're tired, you can't concentrate. And if you can't concentrate, you can't do good work. So, yes, avoid crunch time like the plague, and only work late if it's absolutely necessary. You need you time so that you can actually get the work done. And if somebody tells you that you should be staying late, you should still leave and you should get your sleep while they stay up doing their thing and burning themselves out. All right, so we're hitting the 15-minute mark before I start shutting down the stream. Are there any more questions that anybody has before I head off to the private hangout with the people who signed up? So another question is, when looking through applicants for the character art opening for Insomniac, did you find any awesome ArtStation portfolios? Any good examples of a great applicant? Yeah, there have been several examples of people who had good portfolios. Um, some people who we've sent tests to, some people who just for whatever reason weren't a right fit, weren't the proper fit for what we were looking for. One good example of this is an artist who we looked at. They applied, and their work was very good, but the work that we're doing right now, essentially all of the work that's being done at Insomniac, aside from the VR work being done for things like The Unspoken, is very realistic. It's based on things like scan data and facial, like performance capture, motion capture. We're working with companies that have done a lot of stuff for realistic films as far as like facial animation goes. So it's largely meant to be very realistic and have a degree of um, realistic believability that is sort of in the same ballpark as other big budget realistic games you see out there these days. Your Call of Duties and your Uncharted's and stuff like that. So when we look at somebody's portfolio, we're trying to judge whether or not they look like they could get that kind of work done. So in one instance, we saw someone's work and they had really great work that we all liked, but it simply didn't fit with what we needed them to get done. So unfortunately, we had to pass on that person, even though we liked their work, because their portfolio didn't show any evidence that they could get the work done. Um, they had lots of really great stylized work, but none of it, not even like a concept sketch or anything, showed that they had the capability to do things like work with scan data and stuff like that. Um, and that's a big thing. It's important to be able to know that the person you're hiring is going to be able to do the work, because otherwise they'll simply be unhappy. They won't. They'll be doing work that they don't want to do, and that they, even if they can do it, is just not interesting to them. So the results would end up suffering. In other instances, we've come across people's portfolios or people who have applied, who we had to pass on simply because, well, maybe they had a reputation that would not really fit with the studio culture, which is a reputation that might not be favorable. The studio culture at Insomniac is it's very good. It's very relaxed, and it tries to encourage people to essentially do their best and make sure that they're doing their best while working well with others. It's a very inclusive type of environment, intentionally inclusive. We want people to work with each other because collaboration sort of breeds a healthy environment for making good quality stuff. And some people we have to pass on because even if their work is good, we might know them personally and know that they simply wouldn't work out in that type of culture. Um, so yeah, those are the types of things that might get you passed over even if you have a good portfolio. Um, knowing that you wouldn't be a good fit for some reason or another. Any good examples of a great applicant? Yeah, we have had a few examples of really good applicants, people who either we're personally familiar with, we know their work and know them personally, and those are the types of people who they get a call back and like maybe get an art test or something along those lines. It depends on the person and the situation, and there are often extenuating circumstances. But yeah, if we know somebody who we like personally and who we know does good work, that's a case where yeah, they'll be a good applicant. Can you suggest the best way to learn scan data application for character art? Yes, the best way is to do it. Uh, that might sound like a stupid thing to say, but it's really the only way to actually get your hands dirty with that type of thing. There are tons and tons of resources online for getting scan data, um, and you can either pay for it or get free samples, stuff like that. Um, there, what is it? It's the Infinite Realities head scan. It's the one that you see all the time where people are doing skin shader tests, and it's a bald guy with his eyes closed. You can find that one in various places online for free. It was given away with a Creative Commons license, I believe, and it comes with displacement maps and a color map, and that's essentially the type of thing you'll be working with if you want to do realistic stuff using scan data. So that's the type of stuff you should work with. I'd recommend downloading that type of thing or going to places like the 3D Scan Store or 1024 and getting some of their 3D scans, doing retopo and cleanup on them. A lot of them don't have enough detail for things like pores and that type of thing, so you'd have to add it in ZBrush. So, look into how you can add pores and wrinkles in ZBrush. There are lots of resources online for, skin displacements, skin brushes in ZBrush. So those are the types of things you'll want to look for as well if you want to get into making models from scan data. Lots of scan data out there is, if it's not free, it's very cheap. You can get an entire textured head for like $30. And if you are interested in doing realistic stuff, it's absolutely worth the investment. And it is an investment, and depending upon how you use it, it can even be a tax write-off. So that's something to keep in mind. Yes, scan data. There are different types of scan data. A lot of it comes from just taking pictures of somebody and then assembling those pictures into a 3D model. But scan data also incorporates texture creation and getting different poses for characters, blend shapes, that type of thing. So if you there's a lot more to scan data than just getting kind of crappy triangulated models of somebody that's done with photogrammetry. And you will end up having to clean up scan data at some point if you're working on something that's realistic and uses scanned actors or something like that. So there is a lot to it, a lot more to it than just getting a raw scan. You will end up having to do things like add pores and small little details. There are lots of texture maps you'd have to create, specular and gloss, along with things like translucency. So don't discount the work that goes into it just because you have a good base to start from. There's still a lot of cleanup that needs to be done. And a lot of stuff that you see out there online, while it's good for stills, it's not really set up for animation or general movement at all. So you'll want to give it good topology and good UVs, usable textures, that type of thing. Would I recommend getting an LLC or business license to write off business-related expenses? Uh, that is a good question. One that I am not fully uh, prepared to answer. I do know that if you're doing freelance work in the United States, I cannot at all comment on other countries, and I can only barely comment on working in the US. If you're doing freelance work, or you are doing work that involves you getting miscellaneous income, or uh, doing work where you are buying lots of reference materials for yourself, those are things that you can write off on your taxes as as being, tax deductible, because they are directly related to the work that you do. So in theory, you could write off the cost of, say, signing up for this workshop, um, because it is a business expense and it's something that you are using to directly make yourself either a better employee or a better personal business. And yeah, I can't comment on how things like taxes work in other countries, how write-offs work in other countries. Um, and I am not a tax professional. I am not a law professional or anything like that. So yeah, take it all with a grain of salt and absolutely do your research and talk to a tax professional if you have questions about it. Um, Talk to a CPA, a certified public accountant, if you have questions about taxes, and if you have questions about, say, starting an LLC or something, that's where you'd want to talk to certainly an accountant, but also a business lawyer who specializes in starting businesses like that. They'll have lots of good information for you. All right, and it is 8:56 Pacific time. So I've got about 4 minutes left in the stream before I'm going to shut things down and then hop into the private hangout. Are there any more questions before I just call it a night for now? Right. What is an example of an art test for a character artist? Would you be given artwork and have a week or two to complete the character? Yes, that is more or less what an art test is like, but there are caveats. Um, so an art test is, yeah, essentially you are given a concept or a base to start from or something along those lines, and then um, once you have that, you're given some period of time, and it varies from test to test. You're given some period of time to complete it, send it back, and possibly say take feedback from somebody on the team that you're applying for. That's the general structure of it. A lot of art tests are usually something like a bust or something that will make use of a piece of previously unused concept art, something along those lines. And then from there you'll make something that is essentially the same as what everybody else who applies makes. And it's not really to test the final quality of art that you deliver. Art tests are much more about the decisions that you make between getting the email that says, here's your art test, and the email that you send that says, here's the art test that I just did. So some examples of those decisions you make could be things like, for this art test I was asked to make physically based textures at a certain resolution, and I'm allowed X number of textures. Okay, so there is the instruction that you're given, but then the decisions that you have to make about the instructions are, how am I actually going to utilize these textures? What render settings am I going to use to take advantage of these textures? How well am I going to represent different materials using the textures that I have on hand? Are my textures efficient or not efficient? How did I lay out my UVs? Those are the types of things that people look for in an art test. Certainly, if you want to create a very high quality piece of finalized art for an art test, more power to you. It's also going to mean that you have more work to do. But in general, an art test is to test how you make decisions in a vacuum or in a situation where you are having to respond to feedback. They essentially simulate what the decisions are that you will have to make in your day-to-day job and whether or not you actually make good decisions. So they're less about the final quality and more about, did you make good decisions, and did you apply your knowledge in ways that are efficient and that match what we asked for. So if you can satisfy the did I make good decisions question and the did I follow the instructions questions, that is essentially what the art test is trying to get from you, is the answers to those questions. If you made good decisions, if you responded well to feedback, if you produced something that followed all the instructions and was high quality enough to display that you understand the restrictions and usage of different game art techniques, then that would be considered a fairly successful art test, and that's when usually you would move on to the interview stage. All right, and with that, it is now just after 9 o'clock, and I'm going to be shutting down the stream. Thank you for everybody who tuned in. I know a lot of people came in, dropped out over the course of this thing, but there were a ton of great questions for this stream, and I'm really happy that I got the chance to talk with you guys about all this different stuff while I'm showing some of the process that I use. The next stream will be next Tuesday. That's let's see, what is the date for that? That is Tuesday, August 8th. It'll start at the same time, 7 p.m. Pacific Standard Time, and it'll go for 2 hours. Over the course of the next stream, I'm going to be talking about facial topology, and I'm going to be using some 3D scans as references. I'll be retopologizing a head, or, well, most of a head, maybe not the ears, because ears are time-consuming and topology doesn't matter as much for them. But I will certainly be retopologizing a face and most of a head over the course of the stream, and talking about different ways that you can lay out topology on a face. And then for the stream after that, I'll be finalizing the head and answering more questions and continuing with further workshop material. So now that that's out of the way, have a good night, and I'm going to start, I'm going to get into the private Google Hangout with people who signed up. If you're interested in signing up for this workshop and the private Hangouts where you can get feedback and, talk about job-related stuff or get feedback on your portfolio or any number of other things, I'm on Patreon, and you can just hop on over there. Just use the same username that I have on here on Twitch. It's XCK3D, and you should find me immediately. If you're not interested, that's okay too. You can still watch the streams. So, have a good night, you guys, and I will see you later.